IB Physics questions, day 44. A beam of unpolarized light is incident on the first of two parallel polarizers. The transmission axes of the two polarizers are initially parallel. So let's draw that out. Consider this dashed line to be that transmission axes. And they're going to be the same for each polarizer. But now the first polarizer is rotated about the direction of the incident beam by an angle smaller than 90 degrees. So let's say it's rotated to this point, and this solid line is its new transmission axis. That is going to make this right here theta, which will also be here. This is theta. Those are the same angles. So now, what gives the change in the intensity? Is the intensity different or is there no change? Well, consider the intensity after the first polarizer to be I naught, and the transmitted light intensity is I. So in our data booklet, we have Melas's law. I is equal to I naught cosine squared theta. So now that we have a different angle, one that is not zero, we're going to, because they're not parallel, we're going to have a different value for I. So we can say that intensity is different. So it's either A or B. Now we have to look at polarization. There is going to be no change in polarization because the transmission axis for the second polarizer is always going to remain the same. So regardless of what the light looks like when it's being passed through the first polarizer, the second polarizer or analyzer is always going to put it into what transmission axis it is. Now this is considering for angles that are smaller than 90 degrees. That would not necessarily be true for angles such as 90. So the answer that is correct is answer choice A because the intensity is different and polarization sees no change.